So this is an example of how you'd use Memory1 to do something like a Spark cluster real-time analytics engine, okay? Spark is pretty simple. It has something called a driver, and it goes and lights up a whole bunch of threads on each of these workers, and then they do work, and then they report back, hey, I'm done. And if he has to reduce something and spit out a result, he's going to do the work, okay? But all of the work happens over here. And in the real world, what happens is there's something like HDFS, some file system that's got a whole bunch of data that's spread out across n number of workers. And you say, okay, let's say there's a terabyte that you want to sort. You say, okay, go sort this terabyte. Data is on each of these disks. It gets loaded in by Spark that's running on Java into a whole memory pool of executors. Java has no idea that it's running on Memory1 or anything like that. We just tell it, hey, you have like 100 gig per executor. You have 8 executors. Oh, it says, okay, I have 800 gig, I'm gonna go. Okay, but in reality, it has a bit of DRAM and a lot of flash, and it's none the wiser, okay? So, it just sees a pool of roughly a terabyte in each machine, and it goes off and does its sort, okay? And that's the example that I'm gonna give today. What did I do? Okay. So, here's an example of a machine that actually has 256 gig of RAM in it, but only, about 180 are used. You can actually see 8 Java executors here. This is Spark, and each one has 0.12 virtual 0.12 terabytes of virtual memory allocated to it. And under this, there is actually real physical capacity, which is on our Memory1 solution, which again is DRAM and flash combined, which we control.
The 8-to-1 ratio that you mentioned before, yeah? Right.
Okay. And again, the point here is, look, there's still memory free. Java's running on this. There's all kinds of stuff running on it. Java thinks it has a terabyte here, right? I mean, this is the whole point of me showing you this. It's going to use a terabyte of memory, but this system doesn't actually have it. Okay? It does, in the form of Memory1. So we did a very simple test case. We took a server, right? We stripped out the Memory1. It's just a regular server. It has 128 gig. And this could have been 256. It could have been anything. It could have been any number. We just picked something because we have a comparable example later with the same amount, exact same amount of DRAM in it. Dual core, 56 threads, pretty beefy processor, 14 cores per, 2 SSDs, NVMEs, one for the system, one for the Spark temp files, and we just lit up 8 executors with 12 gig of memory. Not 100, like 12, because if we put 100, it wouldn't work. There is no terabyte in the system. There's 128. Okay? And we ran a sort on 140 gigabyte using something called Spark Perf from Databricks, which is a known provider in the market, third-party benchmarks. So sorting 140 gig, which, by the way, we picked this on purpose, is slightly more than the RAM that it has, to the point we're talking about later, took 27 minutes. Okay? It would have taken like 3 or 4 minutes if this number was like 70 or 80. But because Spark will decompress, bloat, create RDDs, this will probably need about 300 gig, 300 gig of real RAM. So this took a half an hour. Okay? Okay, so the only thing we did was we added the Memory1 and accompanying software into this exact identical system, did not change anything. Okay, and now the sort ran in 4.8 minutes. And these slides, I guess, made available to you. Here is the data coming out from Spark Perf. And the sort took 4.8 minutes. So the only difference, sorry, and I'll turn over the questions. What we did was we started increasing the data size on this machine to see how big we would go and how long it would take. Right, because that's the obvious next step. Okay, so the only thing we did was add our memory to it, rerun the exact same test, okay? And we saw, call it a 7x, 8x delta. Why? Because now it didn't even care. There's no traffic at all going anywhere to anything other than the memory. And of course it goes like stink because everything is local and in memory and our flash is fast, right? So this is the first step of the comparison. Now, again, if you want to reduce this down to a smaller number, it will also run in a few minutes. But who cares? That's not the point, right? Okay, so any questions so far?
So what if I made it 512 gigs and not the Memory1 system, which might be
4.8 minutes, maybe even less.
Again, yeah.
And
well,
it might be even the same amount of money that I have to pay for it.
No.
well, let's keep going.
No, but not that much more, probably.
Let's keep going. Right? Now, we're talking about, so if you are like, you know, Mr. Timmerman, I doubt that you have, you know, 40 terabytes a day of data to sort. But somebody like, I don't know, Tencent or something like that has 40 terabytes of data an hour to sort kind of thing, and it starts to matter, okay? So let's keep going. So now we do a 550 gig job. You ask the question, what happens if I put 500 gig in the system? Well, it turns out you're still going to be screwed. Because with a 550 gig sort, we finished it in 20 minutes, which, by the way, is 30% faster, 50% faster, sorry, than the 140 gig sort. And we actually consumed about 800 gigabytes. We keep track of all the memory that is being used. This sort used almost a full 1 terabyte, okay? And it took basically 20 minutes. Now, and here's all the results, here's all the breakdown, okay? No errors, no recomputations, nothing. And actually now this system is about maxed. Okay, because 550 gig of data creates lots of other data. Okay?
So you mentioned the the delta being like 7 or 8x. Is the price point of Memory1 7 or 8x less than buying a full DRAM solution? You know, how does it compare price
Well, like
to?
I mentioned before, it's 30 to 50% the cost on a per gigabyte basis.
Yeah,
Okay?
yeah.
So let's
what
go to
I'm
the,
saying,
The problem is
hold on, let's go to the next example.
there's no full DRAM solution for it. You have to scale out to another server. You have to buy a full server to do the same thing.
We're going to go to the next example. So now we're going to say, okay, we're going to beef up this system to a 2 terabyte configuration. And actually, this is amazing because I think you can check, and please let me know. I don't know if anybody has ever done a terasort on one machine. I actually doubt it. I didn't have time to look it up before coming to this meeting. Okay, on a one EP dual socket machine with 2 terabytes of Memory1, which was cheap, which is about probably the same cost as the 500 gig that you were talking about before. Okay, 33 minutes. Produced this result last night. For this
you have the
conference.
numbers for that without the Memory1?
Well,
Or would it still be running now?
I know that at 140 gig it took 27 minutes, and so I don't think I have a week to figure out how long it's going to take to run this. Now, it can be done in about 10 minutes on about 15 machines, though. Now, so nobody's saying, listen, that it can't be done in some other way. But I can tell you that our 2 terabyte configuration does not cost our customers the same as 15 machines. Okay? Now, this is cool because this is all running in memory. When we monitor the flash here, it's going like crazy. Okay? And this is all sorts of 100 byte elements. Right? This is key value, 10 bytes for the key, 90 bytes for the value. Pretty amazing stuff. And again, this is the value of a big memory system. Yeah, if you ran this on a machine with 2 terabytes of real DRAM, and probably, and we haven't even optimized this. This is a brand new result. Probably it will run in 5 minutes or 10 minutes. But now you are talking about, well, what is the comparison between 2 terabytes? And I don't know that you can get them in just a generic little 1U pizza box. This picture is misleading. This system was a 1U pizza box. So just going back to your point, for customers that are doing, web scale or hyperscale analytics, I think we just proved with this that they can sort 10 times more data, actually, on one server in the same amount of time, and it did not cost them 10 times the cost of the server. And that's pretty simple math that a customer can digest. And they say, okay, well, great, because I got 40, 50 terabytes I got to do. I'm going to deploy 50 of these servers, and boom, I just replaced 500 servers with 50. I'm very happy.
So Ricardo,
By the way, that's one group, right? Then there's another group doing a different thing, another, and so before you know it, it adds up. So that's kind of the whole point. You're asking, what's the market? This is the market.
So Ricardo, I think there was a question at the very beginning that was said, how was Memory1 accessed? And I think there was a question as to whether it was written to and read from directly, and the implication is that it isn't, and that you're paging, or you're swapping, or you're doing something to allow that access.
It's paging.
It's paging, right?
It's not swap. Swap is not correct.
So are we going to talk about that in the time we have left?
Yeah, but he said he was going to throw something at me if I didn't show him.
I've seen it.
And
No, I was going to throw it right.
Except he was going to
So
throw
Mara
my
was going to
laptop.
cover that. But I felt like people were getting a little impatient, so we had to kind of get to some. By the way, does this answer your question, or is this what you were looking for?
Yeah, it was. I was actually looking for. I was expecting the synthetic benches that you'd done.
Yeah,
on
the
previous
comparison
slide.
to the random, 4K reads with the
What's here?
the histogram at 100,000 operations under 1 microsecond.
But that said, I do think that's better because that's probably more realistic test.
We did have it.
We didn't get a chance to show
We
it.
didn't get a chance to show it, so here's the latency.
This is
so
not
we're-
exactly a histogram.
I will produce a histogram.
Tell him again, you're Italian. You're not supposed to
Maybe
be.
you will be. I think you're being a bit picky, right?
No, I mean, it's fine,
No,
right?
I'm happy. I
Okay,
am, yeah.
but the answer is the bandwidth that we're measuring on a similar test to that 10 gigabyte test. Right now, we're currently at 7 gigabytes. The exact same test. Okay? Now, I'll say every month that passes, our stuff gets faster. I'm being completely honest with you. But right now, we're at 70% of the target we want. This is a 70-30 workload. This is disgustingly fast. And this is the flash traffic. By the way, bandwidth is usually, pretty equal to latency. If you look at this is running here for almost an hour. This is pretty consistently pegged at 5 gig doing 70-30 traffic. These are the reads, these are the writes. And on the previous slide, you can see that every flash element is delivering probably within 10% latency of each other. This little number is 236, 230, 247, 202, 204, 245. Here's the 3.5 reads, 1 and change writes, 1.2 million, 200 microseconds. 10 terabytes of raw flash on 8 Samsung NVMe's at 1.2 million, which is pretty much the peak, 1.5 milliseconds, 300 milliseconds on the writes. They can't even write the data into the controller as fast as we can read it out of the flash.
Hey.
Okay, this is data that is third-party measured. It's apples to apples, 10 terabytes of flash compared to 2 terabytes of raw flash. Okay, it's a completely different game, right, in terms of level of performance, but specialized for memory, not storage.